In question 1, we are asked to integrate the expression here in terms of x, giving our answer in its simplest form. And I will start by writing the expression in index form. So it's the integral of 8x cubed minus 3 over 2x to the minus a half plus 5 dx. Well, we know that in integration we increase the power by 1 and we divide by the new power. So we're looking at 8x to the 4 over 4 minus 3 over 2x to the half over 1 over 2, and then plus 5x plus the constant of integration. Well, I can see that the 8 with the 4 simplified to leave me with the 2 in the numerator, and the 2 with the 2 will cancel out. So we arrive at 2x to the power of 4 minus 3x to the power of a half plus 5x plus c. In question 2, we're given f of x here. It's a cubic expression in x, and we need to use the factor theorem to show that x plus 3 is a factor of f of x. Well, we know that if x plus 3 is a factor, then x is negative 3 is a root of f of x. So we expect f of negative 3 to give a result of 0. So let's see. I will be evaluating f of negative 3, which is 2 times negative 3 to the power of 3, plus 5 times negative 3 squared, plus 2 times negative 3, plus 50. Now this is a show that question, so I need to show some of the calculations here. So we're looking at negative 54 plus 45 minus 6 plus 15, which gives an answer of 0. And therefore we conclude that x plus 3 is a factor of f of x. Now we need to be careful here. If we stop at the result of 0 without a conclusion, we will be penalized. And also if we try to solve part A using long division, we will score 0 because the question is asking explicitly for the factor theorem. In part B, we need to find the constants a, b, and c such that f of x can be written as the product of x plus 3 and the quadratic expression ax squared plus bx plus c. Well, I will proceed with the long division. So I've got 2x cubed plus 5x squared plus 2x plus 15 to be divided by x plus 3. And in long division, I'm always trying to match the highest order term on the left-hand side. So x needs to be multiplied with 2x squared, and this will give me 2x cubed plus 6x squared, and I deduct. So the 2x cubed term will cancel out, and 5x squared minus the 6x squared will give me minus x squared plus 2x plus 15. So I need a minus x here, taking me to minus x squared minus 3x, and I deduct once more, taking me to 5x plus 15. So I will multiply this by 5, taking me to 5x plus 15, and I get a remainder of 0 as expected, which simply means that we can write f of x as a product of x plus 3 and 2x squared minus x plus 5, and therefore we conclude that the constant a is 2, b is negative 1, and c is equal to 5. In part C, we need to show that f of x is 0 has only one real root. So we are solving f of x is equal to 0, and according to the result of part B, this means that either x plus 3 is 0 or 2x squared minus x plus 5 is 0. So if x plus 3 is equal to 0, then obviously x is negative 3. So we've got already one root, the negative 3. Or alternatively, we've got 2x squared minus x plus 5 being 0. Now, for f of x to have only one real root, it means that the quadratic here should yield no real roots. And to do that, I will be considering the discriminant. The discriminant is b squared minus 4ac. So in our case, we are looking at negative 1 squared minus 4 times 2 times 5, which gives an answer of negative 39, which is less than 0. And therefore, we conclude that we have no real roots out of the quadratic. We know that if the discriminant is negative, this means that if I was to apply the quadratic formula, I would have to take the square root of negative 39, which has no real solutions. And therefore, overall, we conclude that f of x is 0, has only one real root, that x is negative 3. In part D, we need to write down the real root of the equation f of x minus 5 is 0. So we're now dealing with a transformation. The x minus 5 means we are translating 5 units to the right. So we are adding 5 to x. And therefore, the original root, which was at the negative 3, we'll see 5 added to it. And we're looking at minus 3 plus 5, which gives a root of 2. Question 3 is on vectors. We've got the triangle PQR such that the vector PQ is 3i plus 5j and the vector PR is 13i minus 15j. And we need to find the vector QR. So to go from Q to R, we can think of this as going from Q to P and then from P to R. Now QP is the opposite of PQ. So instead of 3, 5, it's going to be negative 3, negative 5. PR was given to be 13, negative 15. So I'll be adding the I components and then the J components. So we've got negative 3 plus 13 is 10. And then we've got minus 5 plus negative 15 is negative 20. So the vector QR is 10I minus 20j. In part B, we need to find the magnitude of the vector we just found, the vector QR, giving our answer as a simplified third. So we'll be simply applying Pythagoras theorem here. So the magnitude of the vector QR is going to be 10 squared plus negative 20 squared and all square rooted. This gives an answer of 10 root 5. In part C, we are told that the point S lies on the line segment QR such that the ratio of QS to SR is 3 to 2, and we need to find the vector PS. So it makes sense to draw a straight line segment. We've got S sitting between Q and R. We are told that the ratio is 3 to 2. This means that QS is 3/5 of QR and SR is 2/5 of QR. We're trying to find the vector PS, which we can decompose as PQ plus QS. Well, PQ, we know this is 3, 5, and QS is simply 3/5 of QR because the vector QS is the same as going from Q to R 3/5 of the way. So we're looking at 3, 5 plus 3/5 of the answer we obtained in part A. That was 10, negative 20. So we're looking at 3, 5. Now 3/5 of 10 is 6 and 3/5 of negative 20 is negative 12. Which means that 3 plus 6 is 9 and 5 plus negative 12 is negative 7. So the vector PS is 9I minus 7j. In question 4, we're given a sketch of triangle ABC with all lengths being given in terms of x. In addition, we've got that the angle A is 60 degrees and the angle C is theta degrees. And we need to show that 17x squared minus 35x minus 48 is 0. So I will be using the cosine rule. I will be starting from 3x plus 10. So we've got that 3x plus 10 all raised to the power of 2 is equal to x plus 2 squared plus 7x squared minus 2 times x plus 2 times 7x times the cosine of 60. Well, if I expand the left-hand side, I'm getting 9x squared plus 60x plus 100, which is equal to x squared plus 4x plus 4 plus 49x squared minus 2. I will expand the x plus 2 times 7x, which will give me 7x squared plus 14x. And the cosine of 60 is a half, which is quite handy because the 2 with the half will cancel out. And therefore, we are looking at 9x squared plus 60x plus 100 being equal to 50x squared plus 4x plus 4 minus 7x squared minus 14x. I will further simplify this into 9x squared plus 60x plus 100 being equal to 43x squared minus 10x plus 4. And if I collect all the terms on the right hand side, we arrive at 0 is 34x squared minus 70x minus 96. I will divide throughout by 2, arriving at 0 being 17x squared minus 35x minus 48 as required. In II, we are asked to hence find the value of x, so essentially we need to solve the quadratic equation here. I can use my calculator. The question is not asking for me to show all the working, so I could just run this on the calculator, or I can factorize this. It actually factorizes into 17x plus 16 times x minus 3 being 0. So we either have 17x plus 16 is 0 or x minus 3 is equal to 0. So we're looking at 17x being negative 16, which means that x is minus 16 over 17, or x is 3. However, looking at the diagram, 7x is a length here. This means that x cannot be negative, so I need to reject the negative solution here. I'm going to say reject this. It's not valid, so the only value for x is that x is equal to 3. In part B, we need to find the value of theta, giving our answer to 1 decimal place. So this is the triangle we had. We now know the value of x being 3, so I'm going to go and calculate the length of BC and AB. So for BC, we are looking at 3 times 3 plus 10, which is 19. And for AB, we've got 3 plus 2 is 5. And I'll be applying the sine rule here. So sine of 60 over 19 is equal to sine of theta over 5. I will cross multiply to isolate the sine theta term. So we've got 5 sine 60 over 19 is equal to sine theta. If we do shift sine of the left hand side, we arrive at theta is 13.1735 ... which correct to 1 decimal place is 13.2 degrees. Question 5 is a modeling question. We are told that the mass capital A kilograms of algae in a small pond is modeled through the equation A is PQ to the power of T. Now P and Q are constants. T is the number of weeks after the mass of algae was first recorded. Now we have investigated the linear relationship between T and log A base 10, arriving at log A base 10 is 0.03 T plus 0.5, and we need to use this relationship to find a complete equation for the model in the form A is PQ to the T, giving P and Q correct to 4 significant figures. So starting with A is PQ to the T, it makes sense to take log of both sides base 10. So log A base 10 is equal to log of PQ to the T base 10. Now on the right hand side, I can split the log of the product into the sum of the logs. So it's log of P base 10 plus log of Q to the T base 10, leading to log of A base 10 is log of P base 10 plus T log of Q base 10. Now, in addition, the question has given us that log A is 0.03 T plus 0.5, which means I can compare the coefficient of T. So the 0.03 here corresponds to log Q, and similarly the constant term of 0.5 corresponds to log of P base 10. So we've got log of Q base 10 is equal to 0.03, and log of P base 10 is equal to 0.5, which means that Q is 10 to the 0.03, and this gives an answer for Q, which is 1.072 to 4 significant figures, and P is 10 to the 0.5, which gives an answer of 3.162 for P, and therefore we conclude that A is 3.162 times 1.072 raised to the power of T. Now, with reference to the model, we need to interpret the value of P and the value of Q. So looking at what we have here, the P is the 3.162, and we can see that when T is 0, this is 1, and therefore capital A is 3.162. This simply means that initially we had 3.162 kilograms of algae in the pond, whereas for the value of Q, the 1.072, we can see that each time T increases by 1, then the mass of algae is multiplied by 1.072. Now, a multiplying factor of 1.072 corresponds to an increase of 7.2%, which simply means that every week the mass increases by 7.2%. Be careful here, you need to give your answers in context, so you need to mention the algae, the pond, in order to get both marks. And in part C, we need to find, according to the model, the mass of algae in the pond when T is 8, giving our answer to the nearest 0.5 kilograms, and then the number of weeks it takes for the mass to reach 4 kilograms. So this is the model we were given by the question itself. So I'm not using my model because I'm using rounded values. I'm not sure whether I have the right answers, but this is given in the question. This is surely correct. And the first thing we need to do is find capital A when T is 8. So I will simply substitute T is 8, taking me to log of A base 10 is 0.03 times 8 plus 0.5. This means we are looking at an answer of 0.74 for log A base 10, which means that A is 10 to the 0.74, which gives an answer of 5.4954 ... which correct to the nearest 0.5 kilograms is 5.5 kilograms. Now for II, we need to find the number of weeks it takes to reach 4 kilograms. So when capital A is equal to 4, we're looking at log of 4 base 10 is 0.03t plus 0.5, which means we have log of 4 base 10 minus the 0.5 is 0.03t. And if I divide by 0.03, I get the log of 4 base 10 minus 0.5 over the 0.03 is the value of t. Now if you plug this on the calculator, you get that t is 3.401999 ... And therefore we conclude that the time needed to reach 4 kilograms is 3.40 weeks. Again, our answers need to be in context, so I include the units both for the mass and the time needed. And in part D, we need to state one reason why this may not be a realistic model in the long term. Well, we are looking at an exponential term, so as t goes to infinity, so in the long term, A goes to infinity. This means that the model is predicting unlimited growth, which is unrealistic. In 6a, we are asked to find the first 4 terms in ascending powers of x of the binomial expansion of 3 minus 2x over 9 to the power of 8, giving each term in its simplest form. So we're starting with 3 minus 2x over 9 and all raised to the power of 8. So we start with 3 to the power of 8 plus 8, choose 1, and we've got 3 to the power of 7 times minus 2x over 9. So each time I'm decreasing the power of 3 by 1, and I'm increasing the power of minus 2x over 9 by 1. So the next term will be 8, choose 2, 3 to the power of 6 times minus 2x over 9 to the power of 2. And then it's going to be 8, choose 3, 3 to the power of 5 times minus 2x over 9 raised to the power of 3 plus ... Notice that the sum of the two powers will always be the original power of 8. And then I can plug everything on the calculator, and this leads to 6,561 minus 3,888x plus 1,008x squared minus 448 over 3 x to the power of 3 plus ... In part B, we need to find the coefficient of x squared in the series expansion of f of x defined here, giving our answer as a simplified fraction. So I will start by considering that f of x is x over 2x minus 1 over 2x times the binomial expansion we obtained in part A, which was 6, 5, 6, 1 minus 3, 8, 8, 8x plus 1008x squared minus 448 over 3x cubed plus dot dot dot. I will simplify the first bracket. It's a half minus 1 over 2x times the expression we already have from part A. And then I don't need to do the full expansion. I just need to consider which terms upon expanding will give me an x squared term. So let's consider this. We've got the constant times the x squared term, and then we've got the over x times the x cubed term. So the combination of these two will give me the overall x squared term. So we are looking at dot 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 plus a half times 1008x squared plus minus 1 over 2x times minus 448 over 3x to the power of 3 plus dot dot dot, which is giving me dot 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 plus 504x squared plus 224 over 3x squared plus dot dot dot. I will combine the x squared terms together to give me 1736 over 3x squared plus dot dot dot. And therefore we conclude that the coefficient of x squared is 1736 over 3. We need to be careful here. The coefficient of x squared is just the number and the sign in front of x squared. So it's 1736 over 3. In 7a, we are asked to factorize 9x minus x cubed, and we start by noticing that x is a common factor, so taking us to x brackets 9 minus x squared. Now the 9 minus x squared is the difference of two squares, so this leads to x times 3 minus x times 3 plus x. In part B, we are told that the curve C has equation y is 9x minus x cubed, and we need to sketch this curve C showing the coordinates of the points at which we cut the x-axis. So I will start by writing the factorized form, which is x times 3 minus x times 3 plus x. We know that if we are cutting the x-axis, then y is 0, which leads to x is 0, or 3 minus x is 0, or 3 plus x is 0. So we've got x is 0, we've got 3 is equal to x, and we've got x is negative 3. We're dealing with a cubic equation here, so it's a cubic curve. The leading term, the term in x cubed, is negative, has a negative coefficient, and therefore the shape should be something like this. And therefore, if we draw the axis, we're looking at a cubic curve with a shape something like this, cutting the x-axis at the minus 3, 0, and 3. So this is the curve with equation y is 9x minus x cubed. We're then given that the line L has equation y is k, where k is a constant, and C and L intersect at 3 distinct points, and we need to find the range of values for k, writing our answer in set notation. Now the line y is equal to k, it's a horizontal line, something like this. Remember, we're trying to get 3 distinct points of intersection. So if I move this line up or down, we can see that we've got 3 points of intersection if we are above the minimum and below the maximum. So I'll need to use differentiation to determine the y coordinates of the maximum and the minimum. So I will start by considering dy dx. Now dy dx, we get the power down and we deduct 1 from the power. So 9x will give me 9, and negative x cubed will give me negative 3x squared. We know that at turning points dy dx is 0, and therefore we've got 9 is 3x squared, taking me to 3 is x squared, and therefore we've got plus minus root 3 being the values for x. I will proceed in evaluating y when x is root 3 and when x is negative root 3. So when x is root 3, y is 9 root 3 minus root 3 raised to the power of 3, which gives an answer of 6 root 3. and when x is negative root 3, I'll do the same. We've got y is 9 times minus root 3 minus the negative root 3 raised to the power of 3, which gives an answer of minus 6 root 3. And therefore, if I go on my curve here, the maximum is at root 3, 6 root 3, and the minimum is at minus root 3, minus 6 root 3. All I'm interested in is the y-coordinate of the maximum and the y-coordinate of the minimum, because we want k to be strictly less than the 6 root 3, but certainly greater than the minus 6 root 3. And we need to give our answer in set notation. So my answer is that we've got k such that k belongs to the real, so k is a real number, and minus 6 root 3 is less than k, which is less than 6 root 3. Be careful here, both of the inequalities should be strict. In question 8, we must show all stages of the working, and solutions relying entirely on calculator technology are not acceptable. So we have a modeling question here. We've got the air pressure capital P kilograms per square centimeters in a car tire T minutes from the instant when a puncture was developed, being given by this equation here. Initially, the air pressure was 2.2, and we need to find the value of k. So I will start by saying that when t is 0, we were told that capital P is 2.2, leading to 2.2 is k plus 1.4 e to the 0. Now we know that e to the 0 is 1, so we are looking at 2.2 is k plus 1.4, and therefore the value of k is 0.8. Now, from the instant when the tire developed the puncture, we need to find the time taken for the air pressure to fall to 1 kilogram per square centimeters, and we need to give our answer in minutes to one decimal place. So we've got P is equal to 1, which leads to 1 is K, which we found to be 0.8 plus 1.4 e to the negative 0.5 t, and we're trying to find the value of t. The first thing to do is move the 0.8 over the left-hand side. So we've got 0.2 is 1.4 e to the negative 0.5 t. I will divide both sides by 1.4. So 0.2 over 1.4 is e to the minus 0.5 t. And I will now take a ln of both sides, taking me to a ln of 0.2 divided by 1.4 being equal to negative 0.5 t, and therefore I'll divide both sides by negative 0.5, so 1 over negative 0.5 ln of 0.2 over 1.4 is equal to t. If we plug this on the calculator, we get that t is 3.89182 ... and therefore we conclude that the time is 3.9 minutes correct to one decimal place. Now in part C, we need to find the rate at which the air pressure is decreasing exactly 2 minutes from the instant when the puncture developed. We need to give our answer in kilograms per square centimeter per minute to 3 significant figures. Let's start with the equation for P. P is 0.8 plus 1.4 e to the negative 0.5 t, and we are looking for its derivative with respect to time, so dp dt. Now the 0.8 vanishes, and then the exponential term, I will multiply by the coefficient of t, and I will keep the exponential term. So we've got 1.4 times negative 0.5 e to the negative 0.5 t. So this simplifies to negative 0.7 e to the negative 0.5 t. And I will proceed in evaluating dp dt when t is 2. So this is negative 0.7 e to the negative 0.5 times 2. If I plug this on the calculator, I get an answer of negative 0.2575 ... And we're not surprised that we get a negative value. This is because the air pressure is decreasing, so its rate of change is negative. Well, the question is asking for the rate of decrease. This should be positive, so the rate of decrease is 0.258 kilograms per square centimeters because the negative is incorporated within the word decrease. So this is my final answer for part C. In 9a, we are given that p is log of x base 3 for x greater than 0, and we need to find in its simplest form log of x over 9 base 3 and log of root x base 3. So starting with log of x over 9 base 3, the first thing to do is express this as the difference of two logs. So we're looking at log of x base 3 minus log of 9 base 3. Now obviously log of x base 3 is p, and log of 9 base 3 is log of 3 squared base 3. So we're looking at p minus 2 log 3 base 3, and we know that log of 3 base 3 is 1, and all in all we're looking at p minus 2. In II, we're looking at log of root x base 3. So the first thing to do is write root x as x to the power of a half. The half can come down, so it's a half log of x base 3, which is of course a half p. In part B, we are asked to hence or otherwise solve this logarithmic equation, and we need to give our answer as a simplified fraction. Now, solutions relying on calculator technology are not acceptable, so we need to show all the working clearly. Now, we have already established that log of x over 9 base 3 is p minus 2, and log of root x base 3 is a half p. So I'm going to use this to express the logarithmic equation in terms of x into an equation in terms of p. So we're looking at 2 times p minus 2 plus 3 times a half p is equal to negative 11. I will expand to get 2p minus 4 plus 3p over 2 is equal to negative 11. I will multiply throughout by 2 to get 4p minus 8 plus 3p is negative 22, which leads to 7p is negative 14, and therefore p is negative 2. Now remember, we're trying to find the value for x. We know that p is log of x base 3. So log of x base 3 is negative 2, which means that x is 3 to the negative 2, which is 1 over 9. In question 10, we're given a sketch of part of the curve C with this equation here. The point P lies on C and has x-coordinate 4. The line L is a tangent to C at the point P, and we need to show that the tangent has equation 13x minus 6y minus 26 is 0. So I will start by writing the expression for y in index form. So we're looking at y is a third x squared minus 2x to the power of a half plus 3. I will proceed by finding an expression for dy dx. So we get the power down and we deduct 1 from the power. So it's a third times 2x minus 2 times a half x to the minus a half, and the plus 3 vanishes upon differentiation. This simplifies to 2 over 3x minus x to the minus a half, and I will proceed in calculating dy dx when x is 4. So I'm going to put x is 4, taking me to 2 over 3 times 4 minus 4 to the minus a half, which gives an answer of 13 over 6. I will also proceed in finding the y coordinate when x is 4. So y is a third times 4 squared minus 2 times root of 4 plus 3, which gives an answer of 13 over 3. And now that we've got the point through which we pass and the gradient of the line, we can use y minus y1 is mx minus x1 to find the equation of the tangent. So we've got y minus 13 over 3 is equal to 13 over 6 times x minus 4. I will cross multiply with 6, taking me to 6y minus 26 is equal to 13x minus 52. I will be collecting everything on the right hand side. So we've got 0 is 13x minus 6y minus 26 as required. Now the region R, shown shaded in figure 2, is bounded by the y-axis, the curve C, the line L, and the x-axis, and we need to find the exact area of R. This is the shaded region here. I will start by dropping the perpendicular from P onto the x-axis. We know that the x-coordinate of point P is 4. I'm trying to find the shaded region here, and the idea is the following. I'm going to use integration to find all of this area, and then I will deduct the area of the triangle here. So we already know that P has coordinates 4, 13 over 3. I will call the cut on the x-axis of the tangent to be A, and we know that at point A, y is 0. I will substitute y 0 into the equation of the tangent, so we're looking at 0 being equal to 13x minus 26, so 26 is 13x, so x is 2. So I'm gonna put this here. The x-coordinate of the point A is 2. This means I can do base times height over 2 for the area of the triangle, which will be deducted from the integral of the curve C between 0 and 4. And therefore, we've got that the shaded region R, it's going to be the integral from 0 up to 4 over third x squared minus 2x to the power of a half plus 3 dx minus the area of the triangle, which is base of 2 times height of 13 over 3 over 2. So with integration, we increase the power by 1 and we divide by the new power. So it's a third x cubed over 3 minus 2 x to the 3 over 2 over 3 over 2 plus 3x, and the boundaries are 0 and 4. And the area of the triangle, the 2 with the 2 will cancel out, and this leaves me with 13 over 3. I will proceed in simplifying the expression that is integrated, so x cubed over 9 minus 4x to the 3 over 2 over 3 plus 3x, with the limits being 0 and 4 respectively, minus 13 over 3. And I will proceed in substituting the upper limit first. So we've got 4 to the power of 3 over 9 minus 4 times 4 to the 3 over 2 over 3 plus 3 times 4. And we notice that if we substitute the lower limit of 0, everything here will be 0. So an overall contribution of 0 from the lower limit minus the 13 over 3. Now if we plug this on the calculator, we get an answer of 37 over 9 units squared for the shaded region R. In question 11, we're given the circle here. We are told that the line L has equation 2y plus x plus 6 is 0, and we need to start off by determining the coordinates of the center of the circle and its radius. Well, we know that for a circle centered at alpha beta having a radius of r, the equation is x minus alpha squared plus y minus beta squared is equal to r squared. So the idea is the following. I'll be completing the square here to put it in the standard form, and then I'll be able to just see the coordinates of the center as well as the radius. So we've got x minus 5 squared minus 5 squared plus y minus 4 squared minus 4 squared plus 32 is equal to 0, which leads to x minus 5 squared minus 25 plus y minus 4 squared minus 16 plus 32 is equal to 0. And we've got x minus 5 squared plus y minus 4 squared minus 9 is equal to 0, which leads to x minus 5 squared plus y minus 4 squared is equal to 9. I can therefore see that the center has coordinates 5, 4, and the radius is going to be the square root of the 9, so it's going to be 3. In part B, we need to find the shortest distance between C and L. So this is a diagram we were given. The equation of the line L is 2y plus x plus 6 is 0. We know that the coordinates of the center are 5, 4. I will draw the perpendicular from A to the line. I'm calling the point of intersection B. We know that this is a right angle here. I'll be calling this line here, the line passing through A and B, I will call it L2. And we're trying to find the highlighted distance here. This is the shortest distance between the circle and the line. So I will start by considering the line L with equation 2y plus x plus 6 is equal to 0. The idea is the following. If I can find the gradient of this line, I can use the flipped gradient to find the gradient of AB, which is perpendicular to the line L. So I'm going to put it in the standard form. So we've got 2y is equal to minus x minus 6, leading to y is minus a half x minus 3. And therefore the gradient of the line L is minus a half. Now we know that if two lines are perpendicular, then their gradients multiply out to -1, and this means that the gradient of the line L2 should be 2. I will then proceed with y minus y1 is mx minus x1 to find the equation for L2. So we've got y minus 4 is equal to 2 brackets x minus 5, which leads to y minus 4 is 2x minus 10, and therefore y is 2x minus 6. So I've got the equation of L2, I've got the equation of the line L. I'm going to solve them simultaneously to find the point of intersection, which is the point I've labeled B here. So I'll be substituting into 2y plus x plus 6 is 0, y is 2x minus 6. So we're looking at 2 times 2x minus 6 plus x plus 6 is equal to 0. So 4x minus 12 plus x plus 6 is equal to 0. So we've got 5x minus 6 is equal to 0, and therefore 5x is 6, taking me to x is 6 over 5. I will proceed in finding the corresponding y coordinate. So y is 2x minus 6, so it's 2 times 6 over 5 minus 6, which gives an answer of -18 over 5. And therefore we now have the coordinates of B, which are 6 over 5, comma -18 over 5. So the only thing missing is for me to find the distance between A, B, and then deduct the radius, which is this part here, to find the shortest distance between the circle and the line. So let's go to find the distance AB. So AB, it's gonna be y2 minus y1 plus x2 minus x1 squared and all square rooted. So we're looking at 5 minus 6 over 5 squared plus 4 minus the -18 over 5 squared and all square rooted. This gives an answer of 19 root 5 over 5. And if we go back to the diagram once more, the 19 root 5 over 5 is this distance here. I will deduct the radius, which is 3, to find the shortest distance between the circle and the line. And therefore we conclude that the shortest distance between the circle and the line will be given by the distance AB, which is 19 root 5 over 5 minus the 3. In question 12, we've got a company making drinks containers out of metal. The containers are modeled as closed cylinders with a base radius of r centimeters and a height of h centimeters, and they have a capacity of 355 cubic centimeters. Now the metal used for the circular base and the curved side is costing 0.04 pence per square centimeter, while for the circular top is costing 0.09 pence per square centimeters. We are assuming that the metals are of negligible thickness, and we need to show that the total cost C pence of the metal for one container is given by this expression in terms of R. So I will start by drawing a cylinder here. The height is h, the radius is r. We know that for a cylinder the volume is given by pi r squared h. We know that the volume is 355, so 355 is pi r squared h, which takes me to 355 over pi r squared being equal to h. Now let's go for the cost. Now the cost will be the cost for the base and the curved surface area, which is costing 0.04 pence per square centimeters. So I'll be doing 0.04 times the base area, which is pi r squared, and the curved surface area, which is 2 pi r h. And then I've got the circular top, which is costing 0.09 per square centimeters, so 0.09 pi r squared. Now I will start by expanding this, so we're looking at C is 0.04 pi r squared plus 0.08 pi r h plus 0.09 pi r squared, and I will be substituting h with the 355 over pi r squared we obtained from the fact that we had the volume fixed. And so we've got C is 0.13 pi r squared. I have added up the two pi r squared terms plus the 0.08 pi r times 355 over pi r squared. Now obviously the pi with the pi will cancel out, and then the r with the r squared will leave me an r in the denominator. So we are looking at C is 0.13 pi r squared plus 28.4 over r as required. Now in part B, we need to use calculus to find the value of r for which C is a minimum, giving our answer to three significant figures. Now calculus refers to differentiation in this case, so the first thing to do is write the expression for C in index form. So C is 0.13 pi r squared plus 28.4 r to the negative 1. So in differentiation, we multiply by the power and we deduct 1 from the power. So we've got 0.13 times 2 pi r plus the 28.4 times negative r to the negative 2. This leads to 0.26 pi r minus 28.4 over r squared. And we know that at turning points for a minimum or a maximum, the derivative, the first derivative should be 0. So this is going to be 0, which leads to 0.26 pi r is equal to 28.4 over r squared. I will cross multiply to get 0.26 pi r cubed being equal to 28.4, and therefore we have that r cubed is 28.4 over the 0.26 pi. I will proceed by taking the third root of 28.4 over 0.26 pi. This will give me the value for r, which needs to be given to three significant figures, and it works out to be 3.26. In part C, we need to use the 2c by the r squared to prove that this cost is minimized for the value of r we just found in part B. So we already know that dc by dr is equal to 0.26 pi r minus 28.4 r to the negative 2. I will proceed with the second derivative, so the 2c dr squared is 0.26 pi minus 28.4 times negative 2r to the negative 3. This simplifies to 0.26 pi plus 56.8 over r cubed. I will be evaluating the second derivative at the particular value for r we obtained in part B. So at r is 3.26 ... So this leads to 0.26 pi plus 56.8 over the 3.26 ... raised to the power of 3. Now if you plug this on the calculator and you maintain full accuracy for the value of r, you get an answer which is exactly 39 pi over 80. All we care is that this is greater than 0, and therefore we conclude that the cost is minimized. Now we need to explicitly compare with 0 and write a conclusion to score both marks here. In part D, we are asked to hence find the minimum value of c, giving our answer to the nearest integer. So in other words, I need to take the value of r being 3.26 ... and substitute it into the expression for c, the cost. So this is 0.13 pi times the 3.26 ... squared plus 28.4 over the 3.26 ... Now if you plug this on the calculator, you get an answer for C of 13.052 ... which correct to the nearest integer is 13. Question 13 is on trigonometry. We need to show all stages of the working. Solutions relying on calculator technology are not acceptable. So in part A, we need to show that this identity holds true. So the idea is to go from left to right, show every single baby step along the way, and arrive exactly to the right-hand side. So we've got on the left-hand side the 1 over cos theta plus the tan theta. And the first thing to do is use the fact that tan theta is sine theta over cos theta. So we've got 1 over cos theta plus sine theta over cos theta. I can put this together into a single fraction. So we're looking at 1 plus sine theta over cos theta. Now looking on the right hand side, we need to arrive at cos theta over 1 minus sine theta. So I surely need a cos theta to appear in the numerator, and I can force this to happen by multiplying top and bottom by cos theta. So I'm multiplying by cos theta over cos theta. Essentially I'm multiplying by 1, and therefore we've got that 1 plus sine theta times cos theta in the numerator and cos squared theta in the denominator. Now the next thing to do is consider that sine squared plus cos squared is 1, and therefore the denominator will give me 1 minus sine squared theta, which I should be able to recognize as the difference of two squares. So we've got 1 plus sine theta times cos theta over 1 minus sine theta times 1 plus sine theta. Now it is obvious that we've got a nice simplification. The 1 plus sine theta is cancelling out, and we are left with cos theta over 1 minus sine theta, which is exactly the right hand side as required. In part B, we are asked to solve the given trigonometric equation. Cos 2x cannot be 0, x is in degrees between 0 and 90, and we need to give our answers to one decimal place. Now the first thing to do is realize that the left hand side, the 1 over cos 2x plus tan 2x, is simply the cos 2x over 1 minus sine 2x, using the result we have established to be true from part A, and this is equal to 3 cos of 2x. I will proceed by cross multiplying, so we've got cos of 2x is equal to 3 cos of 2x times 1 minus sine of 2x. I will proceed by cancelling out the cos 2x terms on either side of the equation, because we know that cos of 2x being 0 is not a solution, since we are told explicitly that cos of 2x is not equal to 0, and therefore this leads to 1 being equal to 3 minus 3 sine of 2x, leading to 3 sine 2x being equal to 2, and therefore sine of 2x is equal to 2 over 3. It's time to proceed in finding the principal value. So my PV will be shift sine of 2 over 3. So if I go on my calculator, I'm gonna do shift sine of 2 over 3, and this gives an answer of 41.81 ... So let me write this here, 41.81 ... and I will store this on A to maintain full accuracy. So I write an A here, and we know that when we are solving trigonometric equations involving sine, the solutions are given by the PV, which is A plus 360k, or alternatively 2x will be 180 minus A plus 360k. I will divide throughout by 2, taking me to x is A over 2 plus 180k, or alternatively x is 180 minus A over 2 plus 180k. I can then automate the procedure of determining all solutions by going on the calculator menu, option 9. My f of x will be A over 2. Remember, A is holding the PV of 41.81 plus 180x I press the equal sign. My g of x will be the second equation, so 180 minus the a over 2 plus the 180x. I will ask my calculator to start maybe at -2, go up to 2, and I'm stepping every one. So the calculator will be substituting -2, -1, 0, 1, and 2 into this formulae, and all I see here are the solutions. Remember, we're between 0 and 90, so we see that one solution is at 20.9, so let me write this down. X is 20.9, and another solution is the 69.1, and there are no other solutions within the range of 0 to 90 because the next solution is 200.9 degrees. Question 14 is on proof. We start with a statement that if x squared is greater than 9, then x must be greater than 3, and we need to determine whether or not this statement is true, giving a reason for our answer. Well, if we believe that the statement is true, we need to construct a solid mathematical proof why this must be the case for any value of x. If we are planning on stating that this is not true, that this is false, then it's enough to give a particular example, a numerical value for x, where this statement fails. This is known as a counterexample, and this is exactly what I'm going to do. I start by saying consider x to be -4. Then obviously we've got that x squared is -4 all squared, which is 16, which is greater than 9, which satisfies the first condition here. However, we can see that the value of x, the -4, is actually less than 3, and therefore we conclude that the given statement is not true. In II, we need to prove that for all positive integers n, the expression n cubed plus 3n squared plus 2n is divisible by 6. So let's start with the expression we're given here, n cubed plus 3n squared plus 2n. The first thing we notice is that n is a common factor, so it's n times n squared plus 3n plus 2, which further factorizes into n times n plus 1 times n plus 2. Now, looking at the expression we just obtained and using the fact that n is a positive integer, this means we're looking at the product of 3 consecutive integers. If you consider, for example, 4, 5, 6, then at least 2 of them are multiples of 2, and exactly 1 of them is a multiple of 3. If I was to take 5, 6, 7, this is a multiple of 2, and it's also a multiple of 3. So we can see that at least one of the 3 numbers is a multiple of 2, and exactly one of them will be a multiple of 3, and therefore the overall expression will be a multiple of 6, therefore leading to the conclusion that n cubed plus 3n squared plus 2n is always divisible by 6.